Hello everyone. Today we shall study the DMA subject, that is discrete mathematical structure, first unit, that is the foundations. So in that we shall study the basic concepts. First one is proposition. So what is this proposition? Let me write some sentences. For example, I am Kavita. Next, 2 plus 3 is equal to 5. Today is Sunday. And tomorrow is Monday. Next, 5 minus 2 is equal to 4. So what are these actually? See, I am Kavita. It is a sentence. Next, 2 plus 3 is equal to 5. This is an equation. Today is Sunday. This is also a sentence. Tomorrow is Monday. Again sentence. 5 minus 2 is equal to 4. See, it can be a sentence or it can be a mathematical equation. What is the answer we are getting? We are getting the answer only in the form of either yes or no. For example, I am Kavita. Yes, I am Kavita. 2 plus 3 is equal to 5? Yes. Today is Sunday? No. Tomorrow is Monday? Obviously no. 5 minus 2 is equal to 4? No. So here, yes is nothing but true and no is nothing but false. So, what is this proposition? Proposition is nothing but it is a statement in a given context. It can be either true or false. So, such statements are called as proposition. Next, truth value. So, what is this truth value? As I told you, in the proposition, as a result, we are getting in the form of yes or no. So, the truth or falsity, the truth or falsity of a proposition is called as truth value. True is different, truth is different, okay? Truth means it can be either true or false. So next, logical connective. See, logical connective means, see in English, usually we use some words to combine two sentences. For example, and, or, like that, okay? So similarly here also, connective means what? It connects. What it connects? Two statements or two propositions we can say. So logical means and, or, not, exclusive not, like that. And some words like if, then. Okay. So when such words are used in the given propositions, then new propositions are created. So these words are called as logical connectives. Now, depending on the presence or absence of the logical connectives, we get two propositions. That is simple proposition and compound proposition. What are these? See, for example, let me write proposition. See, usually we represent propositions using small letters like P, Q, R, S. Whatever letters we use them in small letters only. So now, let me write P. P is 2 plus 3 is equal to 5. And Q is 4 minus 2 is equal to 1. So these are the two propositions. Now, I will create one more proposition saying that P and Q. So P and Q means what? 2 plus 3 is equal to 5 and 4 minus 2 is equal to 1. So here I got one more proposition using one word, that is and. So this is called as logical connective. So the obtained proposition is said to be compound proposition. Whereas this proposition is said to be simple proposition. Now, what is simple, what is compound then? Simple proposition means the proposition without any logical connective. Compound proposition means the proposition with logical connective. It can be any logical connective. So now, in the compound propositions, we are having some propositions, that is logical connectives. We shall study them one by one. Now, the first one, okay, so these are nothing but the logical connectives. Let us study the first one, that is negation. So, the meaning of negation is nothing but not. And its a symbol is this one. This is the symbol. So, how to write this? So, for example, the proposition today is Monday. Okay, then what is its negation? Obviously, we have to use the word not. So, negation of P is today is not Monday. So, this will be the negation in terms of statements I am telling you. Now, we have to write the truth table for this. That will be P first, then it's negation. So, if P is 0, automatically it's a negation, or you can say, call it as complement. 0 becomes 1, and if it is 1, it becomes 0. This is in terms of binary value. If we have to create the table in terms of truth values, then it will be P, negation P. So, if P is true, automatically negation will be false. If P is false, automatically negation will be true. So, this is the first logical connective, that is negation. Now, the next one. Conjunction. This is nothing but and this is the symbol. Pause madam. So, conjunction. This is nothing but and your word is used. So, conjunction means what? A new proposition is obtained by using the word and between two propositions. For example, let me take one proposition P. I am Kavita. See, let me take one proposition P as I am Kavita. Now, Q proposition will be I am like the statements using the word and, then it becomes P and Q. I am Kavita and I am a lecturer. So what I have done here, I have taken two different statements and I have combined both the statements using the word and. So this is called as logical connective, which connects two statements, two sentences, or you can say two propositions. Okay. So here the symbol, if I use, then it becomes P conjunction Q. So the meaning of this is P conjunction Q, or in general we can call it as P and Q. Now coming to its truth table. See, when we are having two variables, or you can say two propositions, we are supposed to get four combinations: 0, 0, 0, 1, 1, 0 and 1, 1. So here, as it is and, it means when both the value inputs are 1, then only it is 1. Otherwise, it is 0. So, and meaning is this and that both have to be true. Then only it is true, otherwise it is false. So, in terms of true and false value, what it becomes? 0 means false. So, false, false is false. False, true is false. True, false is false. True, true is true. So this is about conjunction. Now coming to the next logical connective. So now the second one is, third one it is, okay. So the third one is disjunction. So disjunction means or, and its symbol is this one. So exactly reverse of junction. So here again the same definition. How do you define disjunction? Here a proposition is obtained by using the word or to the given propositions. For example, let me write one proposition P as today is Sunday, and Q is 2 plus 3 is equal to 5. Okay, now how do I write disjunction of this? P or Q is today is Sunday or 2 plus 3 is equal to 5. Okay, so here I have taken two propositions and I have combined these two using the word or. So symbolically it should be written as P or Q. So P or Q in generally, here we can call it as P disjunction Q. Coming to the truth table. So inputs are as usual. So here word or means what? This or that has to be true. Okay. So here both are false, hence it is false. Anyone is true? True. Anyone is true? True. Both are true, so it is true. Okay. In terms of false and truth, true, false, true. True, false, true, true, and it is true. So in this way, so this is about disjunction. Now coming to the fourth one. Now the fourth one is exclusive disjunction. So exclusive disjunction, it is nothing but XOR. And this is the symbol. So here again one proposition is obtained by using this exclusive disjunction. Let me take one proposition as 4 is an even number. QB 5 is an odd number. Okay, so here coming to the truth table of this, what it will be as per the symbol P exclusive disjunction Q. So the truth table will be like this. See, XOR, if you remember, what is the definition of XOR? When both the inputs are same, then the output is 0. When both the inputs are same, the output is 0. Else, the output is true. Okay, so this is about exclusive disjunction. Now, the next one is conditional. So this is the symbol of conditional. So here the words are used are if, then. Okay. So how do you use, say for example, the proposition PB. student, okay, and QB, I go to college. So here the proposition P is I am a student and Q is I go to college. Now I am supposed to use these two words, if, then. So where I put this if before the first proposition, okay, where I should put then before the second proposition. Now I write it as P conditional Q if I am a student, then I go to college. So this is how I write. Okay. So now coming to the truth table. So coming to its truth table, 0 0 as usual inputs, 0 1 1 0 1 1. See here, this is bit different here. Conditional means when the first input is 1 and the second input is 0, then only the output is 0, else it is true. Now how to remember this, why it is called as conditional? Let me give you an example. For example, if P is book and Q is study, okay, see the first one 0 0 0 0 means you don't have book, you don't study, okay, you don't have book, that's why you don't study, valid. Next, 0 means you don't have book, 1 means you study. So see, though you don't have book, you study, then it is good. So 1. Coming to the last one, 1 1 means you have book and you study, so that is good. Now the third one is 1 0. 1 0 means you have book but you don't study, which is very bad. That's why it is false. So in this way you can remember this conditional. Now the last one, the last logical connective, that is biconditional. The last one, biconditional. So this biconditional is nothing but XNOR. And this is the symbol. Okay. So for example, let P be 2 plus 2 is equal to 0 and Q be 4 divided by 2 is equal to 0. So then biconditional truth table will be PQ and P biconditional Q. So see here, as I told you, this is nothing but XNOR. So biconditional means, the actual meaning of biconditional is P conditional Q, then Q conditional P. So both are applicable. As a result, we are getting the truth table as XOR. If you remember XOR, what is XOR? When both the inputs are same, then the output is 0, else the output is 1. So XOR is exactly opposite of this. Hence 1 0 0 1. So this will be the truth table of biconditional. So when we study all these logical connectives, we will be able to solve the further compound propositions.